space and time become so warped inside a black hole that they reverse direction. This means that if you were to enter a black hole, you would be pulled inexorably toward its center, regardless of how fast you were moving. As you got closer to the black hole center, your feet would begin to move faster than your head, and eventually, you would be stretched out like spaghetti and torn apart. Our universe is so big that it seems like nothing outside of it can exist. And now physicists are starting to think that our universe may exist inside a black hole. This may sound odd, but it could actually be the best explanation of how the universe began 13 billion years ago. It's a theory that has been explored over the past few decades.
To make a black hole out of the Earth, you need to pack the entire thing into a volume about the size of a blueberry. Most black holes we know of course, are much larger than this, with masses that are billions, tens of billions of times that of the Sun, and with volumes that would encompass our entire solar system. What about the observable universe? We know that the universe is expanding, but expanding into what? Nothing. Space itself is expanding. Because of the particular way that the universe expanded right at its birth, we also know that there are parts of the universe that are currently unobservable to us. They are outside of the so-called observable universe. So there are parts of the universe that are so far away that we can't see them. So the observable universe is defined as this sphere that's around you, that's composed of all the stuff that has had a chance to send a light signal that you could receive. But beyond that, we have no idea how big the entire universe is. So the observable universe right now is 93 billion light years in diameter. But the entire universe, we have no clue. It could be infinite, in fact. It could be something smaller, we don't know. If you wanted to make a black hole out of the entire observable universe, you need to pack it into a sphere that's about a little larger than the current observable universe. Do we live inside an enormous black hole? It turns out that as long as the black hole is large enough, you would be okay. It would still be a one-way trip. Once you cross this event horizon, there's no way for you to go back out. But it's entirely possible that our observable universe right now exists on the interior of an enormous black hole. Black holes are more than astrophysical oddities. And this event horizon becomes a barrier, a border, this thing that's always in the distance, that you can never reach. No matter how quickly you travel, you'll never be able to get to that thing. We know that black holes eat things and grow. So this horizon, think about what it means to be inside of a black hole. You'd have this point of space, this region of space that you could never get to, and it's always receding from you, a horizon. But think about what it then means for you right now on Earth. If you look out into space, there is a horizon very, very far out away, beyond which we cannot see, but we know there's stuff there, but we can never possibly see, and no matter how quickly you travel, you'd never be able to get to it. That's remarkably similar to what you would experience on the inside of a black hole. It turns out that the mathematics of the interior of a black hole is almost identical to the mathematics of the exterior of the black hole. This is actually what is going on. Mathematically, it makes sense as well.
Albert Einstein first predicted the existence of black holes in 1916 with his general theory of relativity. Over the last 100 years, scientists have repeatedly put Einstein's theory of general relativity to the test, trying to find situations or circumstances. The first ever picture of a black hole was captured in 2019, at the center of the supergiant elliptical galaxy Messier 87, which is in the constellation Virgo. It is 500 billion kilometers away from us, but at the same time, it was promisingly big enough, measuring 100 billion kilometers across, and has 6.5 billion times the mass of our Sun. You're looking at a black hole that is essentially the size of our entire solar system.
The problems about black holes that were not solved as of yet and are puzzling to us are, first, the nature of its singularity. What really happens when the curvature of space and time diverges in the interior of a black hole? Is that a channel, a path to another universe? Is there an object there where matter collects? According to Einstein's gravity, it collects at a singularity, and so a paradox arises. In order to discover the world, we need to push boundaries. And the best places to push boundaries is under extreme circumstances, in extreme environments. And the most extreme environments that we know of in the universe are black holes, because they represent places where space and time themselves have a puncture, a behavior that is pathological, that leads to paradoxes within physics.
One of the odd features of general relativity is its ability to bend space and time to the point where time and space can exchange places. Formally, this is where the signature of the space-time metric changes in general relativity. The metric is what tells us how space and time act, and what distances mean at any given point. Intense concentrations of matter can warp space and time so that the metric changes what space and time mean for different observers. The black hole Big Bang theory suggests that, at least for certain forms of singularities, once matter reaches it, it enters a new universe where time at the singularity is the initial point of that universe. This theory is based on the fact that the universe appears to be expanding. If the universe is expanding, then at some point in the past it must have been much smaller. In fact, it may have been so small that it could have fit inside a black hole.
Many physicists say this is the biggest question in physics, because the universe tends to disorder. That's the way it works. Everything gets more and more disordered. But so the Big Bang was a uniquely highly ordered, bizarrely, very strangely highly ordered thing. This is why the universe could have gone in many directions. You know, you often hear say the Big Bang is a quantum fluctuation. There you go, it just fluctuated and it came into existence in this highly ordered state. It's been getting more disordered ever since. But disorder, the measure of disorder is a measure of the probability that you will spontaneously create it. So if you're very ordered, it's very unlikely you'll create it. If you're less ordered, it gets more and more and more likely you'll do it. And that's why things get more disordered. So the universe today is less ordered than it was then. So it's far more likely that it would fluctuate into existence now than it would fluctuate into existence then, because it's less ordered now, so it's more likely. So that means that the whole universe, with us in it, having this conversation, and everything we can see, it's more likely that would fluctuate into existence than it is that the Big Bang fluctuated into existence. And it's clearly true, because it was very highly ordered then, and it's less ordered now. So you're faced with this massive problem that if you want to say it's a quantum fluctuation, it's overwhelmingly more likely, and I mean ridiculously, billions and billions and trillions of times more likely.
If this theory is true, then it means that our universe started out as a tiny speck of matter inside a black hole. Over time, the black hole has evaporated due to Hawking radiation, and our universe has expanded to its current size. This theory explains many mysteries about our universe, such as why it is filled with so much dark energy. It also provides a possible explanation for how our universe came into existence. The idea that our universe may be inside of a black hole is an interesting one, and it's one that scientists are still exploring. While we don't know for sure if this is the case, it's definitely something worth considering. If our universe is indeed inside of a black hole, it would explain a lot about the way things work and how we experience life. It would also mean that there's much more to explore, which is always exciting.